I'm Colin Walls, and I'm here once again to talk about embedded software. Today, I want to talk about a question that I've been asked numerous times at trade shows and conferences and so forth. Now, there's no such thing, in my view, as a stupid question, only the question you didn't ask, because if you need to know something, the best thing to do is ask a question, and chances are other people will want to know the answer as well. So whenever you are at a talk or something, you should always put your hand up if you've got a question and just go for it. The question that I get asked a lot is, what is the memory footprint of a real-time operating system? Typically I'm talking about the nucleus RTOS, and somebody will say, well, how big is nucleus? How much memory does it need? My response to that is always, that's quite a difficult question. It's quite a complex question to answer, which sounds like I'm being evasive, but actually it is just a complex question to answer. There isn't a single response one can give, because there are a whole lot of different variables. Let's think a little about what those are. Now, firstly, memory. What do we mean by memory? We have read-only memory and we have RAM. Read-only memory may well be flash, and RAM, of course, is high-speed SRAM. Nowadays, whilst you can execute code out of flash, it's much more common to copy the flash contents into the RAM. So the memory footprint will actually affect both the amount of flash you use and the amount of RAM you use. So we have code and we have data, and these will be occupying flash or RAM appropriately. So code, first of all, what are the factors that affect code size? Well, the first and most important one is the CPU architecture. If you're using a particular chip, we can specify how much memory some code will take. But a different chip from a different vendor, or even a different chip in the same family, might well have a very different memory footprint. The next thing is compiler optimizations. If you build the RTOS, or any code for that matter, with different settings on the compiler, then you'll get different size code. So you need to know the answer to how was the RTOS built. Another question is scalability. Modern real-time operating systems tend to be scalable, which means that the size of the operating system varies depending on which functionality, which items you choose to incorporate in the operating system. And lastly, there is the runtime library. Are we including that or not in our estimate of memory footprint? So all of these factors, you need to know what assumptions were made if somebody tells you what the answer is. The same goes for data. Now, a certain amount of data is needed by the real-time operating system, so how much space does it use? Well, again, there are a bunch of factors that affect this. Firstly, there is compiler optimization. Again, you can organize how data is stored in memory with varying degrees of efficiency. It might be compact but take longer to access, or vice versa. Another thing which affects data is the number of RTOS objects. How many mailboxes have you got? How many tasks have you got, for that matter? All these objects will occupy a bit of RAM each, most likely, and therefore you need to know how many to know what the footprint means. Each task will have its own stack, so we need space for the stacks. How big are they? Well, that depends on the complexity of your code, and that will vary very drastically, but obviously we do need to allocate space for those in RAM. And lastly, things like memory pools. An RTOS object uses a certain amount of RAM, but certain objects, and the most obvious one being a memory pool, require an area of memory given to them to operate. So this will occupy a certain amount of RAM. Does all these factors. So if somebody says to you, this operating system is size X, you've not received any useful information unless you understand what all these elements are contributing to that. So how do I answer the question, apart from saying it's difficult? Well, I would discuss the subject in a little more detail, and then I could say something like this. Nucleus RTOS running on an ARM Cortex A8 in ARM mode yields a ROM size of 12 to 30K and RAM of 500 bytes. The low-end ROM size includes the essential services. The high value includes all services. The runtime library is excluded. Building the RTOS for Thumb 2 mode reduces the ROM size by more than a third. Is that a good enough answer? Well, I think it's good enough for you to understand what we're going for with the Nucleus real-time operating system. It gives you an order of magnitude. You know you're not talking about multiple megabytes of code, but you also have a clear view that it will be variable according to these various parameters. I hope that's useful when you're considering using a real-time operating system. There are many other factors which help you select one, and that's maybe something I'll talk about another day. But for now, that's it. Bye for now.